Solve the system by graphing 2x plus y equals 1, 3x minus y equals 9. To solve the system by graphing, we need to graph both equations and then find the point of intersection, if one exists, between the two equations. To do that, let's find a series of ordered pairs to plot for each equation. We'll start with the first equation, 2x plus y equals 1, and we'll create a table of values. Let's first find the y-intercept where x equals 0. If x equals 0, then y equals 1. If x equals negative 2, then y is equal to 5. And if x equals 1, then y is equal to negative 1. We then have our other equation, 3x minus y equals 9. We'll create a table of values here. We'll first let x equal 1. When x is 1, y is equal to negative 6. Then let's let x equal 2. When x is 2, y is equal to negative 3. And finally, we'll let x equal 3. When x is 3, y is equal to 0. That's our x-intercept. Now that we have 3 points for both equations, we can graph each equation. We'll start by graphing 2x plus y equals 1. To do that, we'll let each dotted line on our coordinate grid represent 1 unit. So the maximum on each axis will be 6, and the minimum will be negative 6. And we'll first plot the y-intercept, 0, 1. So we find 1 on the y-axis and plot a point. We then plot our point negative 2, 5. From the origin, we move left 2 and up 5. And we have a point 1, negative 1. From the origin, we move right 1 and down 1 unit. We connect these 3 points with a straight line in order to graph the equation 2x plus y equals 1. Now let's graph 3x minus y equals 9. We have the point 1, negative 6, so from the origin we move right 1 and down 6 units and plot a point. We then have the point 2, negative 3. From the origin we move right 2 and down 3 units. And we have the x-intercept 3, 0. So we find 3 on the x-axis and plot a point there. We then connect these points with a straight line to graph the equation 3x minus y equals 9. Remember that we're solving this system. To solve a system, we find the point of intersection when we graph each equation. Notice that these graphs intersect at the point 2, negative 3. Therefore, the solution to this system is the point, or looks like the point, 2, negative 3. We do need to verify that by substituting into both of our equations, because it's possible we could have graphed and our graph could be slightly off. So let's check. In our first equation, if we substitute these values in, we'd have 2 times 2, which is 4, plus negative 3, which is 1, equals 1. That checks out. And then for our second equation, 3x minus y equals 9, we did already find that the point 2, negative 3 satisfies this equation. But let's just verify again. 3 times 2 is 6, minus negative 3 is plus 3, 6 plus 3 is 9. So this solution does check, and the solution set is the set containing the ordered pair 2, negative 3.